Hello students, welcome to Dr. B.R. Ambedkar Open University. Today we are going to discuss about measures of variation and skewness. As we discussed in measures of central tendency, that a central value alone cannot explain about the distribution. We have to see how much variation is there in the data points, and so for that we have to calculate measures of variation. First, let us understand what is the meaning of variation. Variation refers to the how the data points in data set differ from each other. For example, if all the data points in a data set are equal to 5, then there is no variation among the data points. If one is 5, the other one is 10, another one is 30, like that, if the data points are there, then the variation is more. In other words, the measures of variation measure the spread or dispersion of values in a data set from the average. The greater the variation, the more spread out the data points are from the average. Calculating variation in statistics is very important for several reasons. It helps provide a clear understanding of the data set. So, let us understand the reasons why we have to measure the variation. First thing, as we have already discussed, it helps us in understanding the spread of the data points in the data set from the mean. Without this information, you might assume that all the data sets with the same average are the same. So, but variation helps us in understanding the differences in the data sets. It helps us in understanding how the data points in the data sets are diverse or concentrated around the mean. So, it helps in understanding consistency in many fields like quality control, finance, health. Consistency is very important. A data set with low variation from the mean, the values a data set with low variation means the values in the data set are close to each other and to the mean and suggest stability in the data set. High variation indicates uncertainty or inconsistency. So, and the second important reason which we have already discussed is to compare data sets, we can use variation. Two data sets with the same mean might have very different variations, which means they behave differently. Knowing the variation can reveal important differences in the data set that are not immediately noticeable with the help of averages. It helps us in understanding the risk. In fields like finance or healthcare, variation is closely linked to risk. For example, in investing, the higher the variation, the greater the risk involved. So, if the price of a share varies violently, volatility is very high, then it is better to avoid that stock because there is high risk in investment. And variability is also essential for making inferences about population from a sample. Statistical tests such as t-test, ANOVA often rely on understanding variation to determine if observed differences are statistically significant or they could have occurred simply by chance. In identifying outliers also, variation is important. High variation can indicate the presence of outliers in the data set. Identifying outliers help us in further analysis, decision making and data cleaning. There are several measures of variation. They are range, interquartile range, semi-interquartile range, which is also known as quartile deviation, coefficient of quartile deviation, mean deviation, coefficient of mean deviation, standard deviation, variance and coefficient of variation. Let us first understand range. In statistics, range is the simplest measure of variation. It represents the difference between the highest and lowest values in a data set. It means that the maximum value and minimum value, by subtracting minimum value from the maximum value, we get the range. In a data set, if there are the data points are 18, 22, 25, 29, 35, 40 and 50, highest value is 50 and lowest value is 18 and the range is 32. It is very easy to calculate range and it gives a quick idea of the spread of the data set. However, range depends on the two extreme values. If the data set contains outliers, the range can be misleading. So, because if one value is 100 and the other values are close to 10 and then the range is 90, but 99% of the values are not close to 90 and 100, hence range is misleading. While the range is false, in the range tells the total data spread of the data set. It does not give information about the distribution or how values are spread around the mean or how the extreme values are different from the other values in the distribution. So, there is another measure of variation which is called interquartile range. So, it explains about the middle 50% of the data set. The interquartile range is very useful because it focuses on the core of the data, that is middle 50% of the data, and it is less affected by outliers or extreme values unlike range. Interquartile range is calculated by subtracting Q1 from Q2. So, we have to calculate Q1. For that we have discussed when we discussed about measures of central tendency, how to calculate Q1. First we have to arrange the data set in ascending or descending order, then we have to calculate Q1 and Q3 and for example, if the data set arranged data set is 50, 55, 60, 65, 70, 75, 80, 85 and 90, Q1 is equal to 57, Q3 is equal to 82.5 and interquartile range is 82. IQR, which means interquartile range, is useful when to identify the outliers in the distribution. If we want to detect outliers using interquartile range, first we have to calculate the lower bound by subtracting 1.5 times of the interquartile range from Q1, and we have to calculate upper bound by multiplying interquartile range with 1.5 and adding it to Q3. These two values are considered as outliers of the distribution. And the next measure of central tendency is quartile deviation. Quartile deviation is also known as the semi-interquartile range. The name itself explains how to calculate it. So, we calculate the interquartile range by subtracting Q1 from Q3 and divide it with 2 and we get the quartile deviation. So, it is a measure of the spread of the middle 50% of the data set as in the case of interquartile range. It gives an idea of the dispersion of the data focusing on the range between the first and third quartiles. It is essentially half of the interquartile range, as I already pointed out, and it is less sensitive to extreme values than other measures like range. Formula we have already discussed, quartile deviation is Q3 minus Q1 divided by 2. So, the next one is coefficient of quartile deviation. Any coefficient is a relative measure. it is independent of unit of measurement. For example, if we want to compare two data sets, one is height and another one is weight. So, these two are two different measurements. So, in such cases, to compare the distributions in terms of their dispersion, we have to use coefficients, and coefficient of quartile deviation is one such measure. When the dispersion of two data sets with for example, coefficient of quartile deviation is equal to Q3 minus Q1 divided by Q3 plus Q1. The value of quartile deviation, coefficient of quartile deviation varies between 0 and 1. When we compare two data sets, the data set which has more coefficient has more spread. 0 quartile deviation, coefficient of quartile deviation means there is no dispersion in the data set. The next measure of variation is mean deviation. Mean deviation explains as the spread or dispersion of data point in a data set. It represents the average of the absolute differences between each data point and the mean of the data set. So, what we have to do is we have to subtract each value in the data set mean we have to subtract from each value of the data set, and that difference we have to ignore signs, because there is a mathematical property. The sum of the deviations of data points in a data set from the mean is equal to 0. To avoid that, we ignore signs while calculating the differences of data points from the mean. It provides a sense of how much the data points deviate from the central value of the distribution. Mean deviation is equal to sigma x minus x bar divided by n. X minus x bar means each value of the data set, from each value of the data set we are subtracting the mean and we are adding the differences by ignoring signs. So, we put parallels to the values and divide it with n. The mean deviation gives a sense of the average distance of data points from the mean. It uses absolute values, so it does not consider the direction plus or minus. That means, as I already pointed out, if we consider those signs, the mathematical property of arithmetic mean explains that the sum is equal to 0. Mean deviation can be sensitive to outliers because each data point contributes to the final result. It is less commonly used than other measures like standard deviation or variance, especially in more advanced statistical analysis. We use only standard deviation or variation in advanced statistical analysis and not the mean deviation. This is because mean deviation lacks certain mathematical properties which standard deviation and variation have. We can calculate coefficient of mean deviation also. As I already mentioned, if we want to compare two distributions with two different scales of measurement, then we have to use coefficient and not the mean deviation. The coefficient of mean deviation is a relative measure of the spread of dispersion of a data set. It standardizes the mean deviation, that means it will not give us the unit of measurement of the data set, and it makes us easy to compare two data sets with two different units of or different scale. Coefficient of mean deviation is equal to mean deviation divided by mean. Mean deviation can also be calculated from median or mode, but usually we calculate only from mean deviation from the mean. Hence, we calculate the mean deviation with mean. By dividing mean deviation with mean, we get coefficient of mean deviation. The next measure of dispersion is standard deviation. Standard deviation measures the spread or dispersion of a set of values. It indicates how much the values deviate from the mean of the data set. A low standard deviation means that the data points are close to the mean, while a high standard deviation means that the data points are spread out over a wide range. You may ask one question: when mean deviation is also calculated from the average and standard deviation is also calculated from the average, what is the difference between the two? In the case of mean deviation, we ignore signs of the deviations. In the case of standard deviation, we do not ignore the signs of the deviation, but we square the deviations, because the signs are the minus signs will become plus when we square them up. How to calculate standard deviation? Let us understand the procedure. First, we have to find the mean of the data set and subtract the mean from each data point to find out the deviation, and we do not ignore signs, we keep the signs unless in the case of mean deviation, and we square each deviation to make them positive. Find the average of the squared deviations. Because we squared the deviations, now we find out the square root of that, so that the original value will be restored. Find the average of the squared deviation, which this is also known as variance. Take the square root of the variance to find the standard deviation. So, that means if we do not take the square root of the value, then it is called variance. If we take the square root, then it is called standard deviation. The formula of standard deviation is sigma deviations, that means x minus x bar divided by sigma x minus x bar the whole square divided by n, and if we do not take the square root, it is variance, and if we take square root of it, it is called standard deviation. The standard deviation is always non-negative, it cannot be negative, and has the same units as the data. For example, if the data set is in rupees, standard deviation is also in rupees. It increases if the data is multiplied by constant, which means that if you multiply each value of in the data set by 5 and calculate standard deviation will also increase by 5, and it does not change if a constant is added to all data points. So, if we multiply the data, standard deviation will increase. When we add a particular value to each point in the data set, then the standard deviation will not be affected. The standard deviation is, as I already mentioned, is the square root of the variance. These mathematical properties make the standard deviation a very useful tool in statistics for measuring how spread out data is, as well as the comparing different data sets or distributions. As mentioned earlier, the square of standard deviation is known as variance, because without square root we calculate the variance. Once we take the square root, if we again the value is squared, we will get variance. The square root of variance is called standard deviation. In some of the statistical applications, variance has special significance, hence we calculate variance instead of standard deviation. The next measure of dispersion is coefficient of variation. It is very useful measure to find out the consistency or inconsistency in a data set. It measures the relative variability of data sets. That means, for comparison purpose of data sets, coefficient of variation is very useful. It expresses the standard deviation as a percentage of the mean. This makes a tool for comparing the variability of data sets with different units of scales. Coefficient of variation is equal to standard deviation divided by mean multiplied by 100. If the coefficient of variation is high, it shows more variability, and if the CV is, that means coefficient of variation is low, it shows less variability or more consistency. It is useful for comparing data sets with different means and different standard deviations. What is the practical utility of coefficient of variation? Let us understand. In risk assessment in finance, when we want to compare the risk and returns of various investment opportunities, we need to calculate coefficient of variation. the data, the investment opportunity which has less CV means the returns are more consistent and the variations in returns are less. If the CV is very high, the returns are, there is lot of variations in the returns over a period of time. I will give another example, practical utility of coefficient of variation. For example, take a cricketer whose average runs is 100 and take another cricketer whose average runs is 80. And in the case of the batsman who has 100 average runs, and if he ducks out in one match and scores 200, and in another match another 1 run, in another match 250 runs, like that, and another person who scores consistently 80-90 runs in every match, then the second batsman is better than the first batsman because he has consistency as compared to the first batsman. And in another area where we can use coefficient of variation is quality control. In production processes, the lower coefficient of variation means less variation, particularly in pharma production. This is very important. We cannot accept even, we cannot take even 0.001% risk in the quality. In medical research, for example, in blood pressure, to measure blood pressure variability across different groups, we can use coefficient of variation. In sales and business analysis, for example, to compare sales performance consistency of various sales people, we can use coefficient of variation. In agriculture studies also, to find out the consistency in the yield of crops, we can calculate coefficient of variation. So, these are the practical utilities of coefficient of variation. This is one of the very good measures of variation, particularly for comparison purpose. After understanding the measures of dispersion, now let us understand skewness. You may ask, what is the difference between measures of variation and measures of skewness? Measures of variation help us in understanding the variability of the data sets. Measures of skewness help us in understanding the direction of that variability. Skewness refers to asymmetry or lack of symmetry in the distribution of data. Symmetrical distribution means when we divide the distribution into two parts, the first part is exactly equal to the second part. If the distribution is that, such distributions are known as normal distributions. Skewness indicates whether the data set is skewed to the left, that means negative skewness, or skewed to the right, that is positive skewness relative to the mean. What are the types of skewness? As I have already mentioned, skewness can be divided into two types: positive skewness, which is also known as right skewness, where the right tail of the distribution is longer or fatter than the left tail. If the normal distribution is there, in the case of normal distribution, there is no tail in the distribution. In the case of skewness, the tail will be either on the left side or on the right side. If the tail is on the right side, it is called positive skewness. In such cases, the mean is greater than the median. Let us take income distribution. Very few people earn more money than the rest of the people. So, the number of such people is very number of billionaires. For example, you take the number of billionaires, the number is very less. So, that means when in a distribution, the tail is on the right side. Negative skewness means there is a left tail. The left tail of the distribution is longer or fatter than the right tail of the distribution, or there may not be any tail in the right side also. In such cases, the mean is less than the median. For example, take age of retirement. Very few people retire at lower age, and many people retire at 60 or more than 60. So, since most people retire in their 60s and very few people retire earlier, there will be a left tail in the distribution. So, the number is very less. So, the tail is on the left side. It is called negative skewness. Skewness can also be viewed from other angles. Zero skewness. The third type is zero skewness. Zero skewness means the distribution is symmetrical. That means it is a normal distribution. So, when the distribution is symmetrical, the left and right tails are mirror images of each other. They exactly the one side is equal to the other side. The mean is equal to the median. In the case of normal distribution, mean, median and mode are the same, and it is a bell curve. It is bell shaped. There are two methods to calculate skewness. One is called Karl Pearson's coefficient of skewness, the other is called Bowley's coefficient of skewness. Karl Pearson's coefficient of skewness is based on the difference between mean and standard deviation, and Bowley's coefficient of skewness depends upon the quartiles and median. Karl Pearson's coefficient of skewness is a measure of the asymmetry of the distribution of data around its mean. It quantifies the extent and direction of skewness, whether the data are positively skewed or negatively skewed, we can understand with the help of Karl Pearson's coefficient of skewness. In a symmetrical distribution, mean is equal to mode. In a positively skewed distribution, mean is greater than mode. So, to calculate Karl Pearson's coefficient of skewness, we have to subtract mode from mean and divide it with standard deviation. In a symmetrical distribution, mean is equal to mode, hence Karl Pearson's coefficient of skewness is 0. And if mode is ill defined in a series, first we have to find out the mode with the help of the formula 3 into x bar minus 3 median minus 2 mean, and then we have to calculate the standard deviation, and then we have to calculate the Karl Pearson's coefficient of skewness. And let us now understand Bowley's coefficient of skewness. Bowley's coefficient of skewness is another measure of the skewness of data distribution. It is based on quartiles rather than mean and mode. This method is particularly useful when dealing with data sets that may have outliers and non-normal distributions. Bowley's skewness is calculated by using the first quartile, third quartile and the median. So, in normal distribution, Q3 plus Q1 minus 2 median is equal to 0. In skewed distributions, it may be the difference may be positive or negative. If the difference is positive, there is positive skewness in the distribution. If the difference is negative, then there is negative skewness in the distribution. And we can also calculate Bowley's coefficient of skewness by using formula Q3 plus Q1 minus 2 median divided by Q3 plus Q1. Positive skewness means, as I already pointed, this coefficient is positive. Negative skewness means the value is negative. In if the mean of the distribution, this means the distribution is longer or fatter right tail. Let us now understand Karl Pearson's coefficient of skewness. Karl Pearson's coefficient of skewness is a measure of the asymmetry of the distribution of data around its mean. It quantifies the extent and direction of skewness, whether the data are positively skewed or negatively skewed. In a symmetrical distribution, mean is equal to mode. In positively skewed distribution, mean is greater than mode and vice versa. The coefficient of skewness is equal to 3 into x bar minus mode divided by standard deviation. In a bimodal distribution, mode is ill defined. Hence, mode is equal to 3 median minus 2 mean, and we have to adjust the formula accordingly and calculate the Karl Pearson's coefficient of skewness. If it is positive, the skewness is positive. If it is negative, the skewness is negative. Next measure of skewness is Bowley's coefficient of skewness. Bowley's coefficient of skewness is like Karl Pearson's coefficient of skewness measures the skewness in the distribution. It is based on quartiles and not based on mean and mode as in the case of Pearson's coefficient of skewness. This method is particularly useful when dealing with data sets that have outliers or the distributions are non-normal. BRAOU's skewness is calculated using the first quartile and the third quartile and the median. BRAOU's coefficient of skewness, which is the short form of which is SKB, is equal to Q3 plus Q1 minus 2 median divided by Q3 minus Q1. If the value is positive, it is positive skewness or right skewness, and it is greater than 0. The data is if when it is greater than 0 and positive, we say that the distribution is positively skewed or right skewed. In other words, the the distribution has a longer or fatter right tail. The mean is typically greater than median, and there is a concentration of data towards the left. What is the utility of skewness? Skewness helps in understanding the shape of the distribution, whether the distribution is normal distribution or it has right tail or left tail, we can understand with the help of the skewness, coefficient of skewness. It also helps in understanding the direction of the variation. As I have already mentioned, measures of variation gives us only whether variation is there or not in the data set, but skewness helps us in knowing the direction of that variation, whether the direction is in positive side or negative side, we can understand with the help of skewness. Many statistical calculations involve the assumption of normality of the data set, particularly in hypothesis testing. We assume normality of the data sets when we want to infer from the sample mean about the population mean. Skewness helps us in understanding whether the data meets the assumption of normality or not. If the data are not normal, we have to normalize them before taking a decision, before calculating the other values. So, hence skewness helps us in understanding about the normality of the data set, and hence skewness is very helpful in further statistical calculations. Thank you very much.